So today we're going to revise forces. Forces in your book, Unit 4, Section 3, from page 91, 98 to 101. Our objectives for today is to define what is meant by force, to understand how to measure forces, and to describe the effect of forces on motion. Okay, so how can we define force? Force is a push or pull on an object. So it's just as simple as that. Whenever I want to define force, what is a force? Force is a push or pull, because whenever you apply a force, you apply it in a form of pushing an object or pulling an object. Now, to describe the force applied, we describe it by strength and direction. So I need to know the amount of force, how strongly you applied your force, and I want to know the direction you applied your force in to understand how your force affects on the object. So for example, if I give you this ball, okay? Now, if the ball is at rest, it means that it's not moving. Now, if you apply the force on this ball, your force may cause the ball to move or not. Yeah, so it may cause the ball to move, or it may not cause any effect. If the ball is already in motion, the force you apply may slow it down, or maybe speeds the ball up, or maybe changes the direction. Okay, so a force gives an object energy to stop moving if it's already moving, start moving if it's at rest, maybe changes direction, and even changes the speed of the object. Now, how to measure force? You remember how to measure force. Not how to calculate, how to measure. Yes, Lynn?
Yes, teacher. It's we measure it by a force meter or Newton meter.
Excellent. Bravo, Lynn. So we measure force by using force meter or Newton meter. Excellent. Like the one you have it here, okay? Or a strength scale also, but we prefer to say Newton meter or force meter. Now, the unit of force equals, or it is newtons. And remember, we use capital N to represent Newton. Now, types of forces. We have mainly two types of forces. Who can tell me what are the two types of forces? The main two types. Yes, Zed.
Push or pull.
Bravo, this is in general. Whenever you apply, you pull or push. But we classify forces in a different way. Yes, Tala.
Contact and non-contact.
Bravo, yes, bravo. So forces are two types. Contact force, like friction, and non-contact force, like gravity and magnetism. You can tell me the difference between contact and non-contact. What does it mean, contact force? What does it require? Yes, Natalie.
Contact force means like the object is in touch with the other object.
Yes, bravo. It's in contact or in touch with the force.
Yeah, and the non-contact force, it means like two objects are having a force between them with no touch.
Bravo. And how that can happen? The force must have what?
Like they should have for example, in the magnetism should be having a field in which when we put two magnets.
Yes, amazing,
What?
amazing. Yes, right, amazing.
Yeah.
Thank you. Bravo. So for non-contact forces, this type of forces, they already have a field of effect, like gravity. We have a field of gravity, yeah? Magnetism, also it has a field. The same as electricity, there is the electrical field, there is a magnetic field and the gravitational field. Bravo. So contact force requires a direct contact between the object and the force, like friction. Objects must be in touch, in contact. Non-contact forces, it's for forces that have field around. Bravo. Yes, Muhammad Haddad.
No, teacher, I forgot my hand raised.
Raise your voice, please.
I forgot my hand raised.
It's okay. Oh, amazing. Bravo. Well done. Now, whenever I'm talking about forces, to know how the force is going to affect on the object, will it affect or not? And especially if I have more than one forces acting on the object together, in this case, we need to find the net force. And what do I mean by net force? Remember that net force is the combination of all the forces acting on an object. So net force is the combination. Calculate the net force. If the forces acting in the same direction, we add them together. And if forces are acting in opposite direction, in this way we subtract. So whether we add or subtract. Now, of course, we do have other ways that you're going to learn in the coming years, but mainly for now, we're going to learn if the forces are acting in the same direction or opposite directions. So let's do the first example. If I have a force of 10 Newton to the west acting on an object, and another force of 5 Newtons acting on the object to the east. If I want to find the net force, now first of all, I have to pay attention at the direction. So one, it's acting to the west, and the other one to the east. Opposite directions. Since opposite directions, so I have here to subtract, and the net force is going to be 5 Newtons to the west. Why to the west? Because it's the direction of the greater force here. Okay, let's have another example. 10 Newtons to the east, acting on an object, and another force also acting on the same object with 5 Newtons also to the east. So first I look at the directions. East and east, they're the same direction. Since it's the same direction, here I add forces together. The last one, I have 10 Newtons to the west, 10 Newtons to the east. So opposite directions, we subtract. The result is 0. Now, whenever the net force is 0, we call this balanced forces, okay? Balance means it's 0, not gonna affect, okay? Here, okay. Now let's do the second one, this one. Also here, I have an object, and two forces are acting on the object. One, it's upward, and the other one, it's downward. One, it's 1200 and 800. So first, I look at the direction. Opposite directions, we subtract. And we take the direction of the greater force, which is 1200. So the result is going to be 400 Newtons upward. Another example also here, we have 600, 800, opposite, we subtract, and the net force is going to be downward, which is the direction of the greater force. Now, who can tell me how to solve the third one? I have two forces acting in opposite directions, and the third one that's totally in a different direction. Yes, Raghat.
We subtract 50 from 50, which is 0, and for the other direction it's 20. So the answer is 20.
Bravo, Raghat. Thank you.
You're
So first look at these two directions, the upward and the downward forces. Since they're opposing each other, so directly subtract. 50 minus 50, it's 0. So there is no effect of these two forces. What is left is 20 Newton to the left. So the net force is going to be 20 Newton to the left. Bravo. Let's have another example. Who can tell me how to solve this one? Let's see, who's going to solve this one? Yes, Mariam. Mariam? Okay. Jude Khawaja?
10 newtons to the right plus 10 is 20 Newton.
Bravo.
And there's 7 newtons to the left, so it's 30 newtons to the right. The final answer.
Again, so you're going to add 10 newtons plus 10 newtons, yeah?
Yeah, and
So
then
it's
7.
20.
Yeah, and then 20 minus 7, which is 13. 13
Bravo,
newtons.
Jude. Yes, excellent. Thank you. So yes, bravo. First of all, I have 3 forces. So I look at the direction. 2 of them are acting in the same direction, so we add them together. So 10 plus 10 is going to be 20 Newton. So I'm done with the forces acting in the same direction. Now I have another force acting on an opposite direction. So in this case, I'm going to subtract this force. So 20, the total of the 2 forces acting to the right, minus 7 newtons, which is the force acting to the left. The total is 13 Newton. But where is the 13 Newton acting? It's acting to the right, okay? Okay. Now, let's discuss friction. We just said that forces are 2 types, contact and non-contact forces. In case of contact, objects must be in contact, in touch, in direct touch. So, who remember how to define friction? Sarah Razan. Will you define or will you tell me what is friction? I don't have audio, Sarah. I can't unmute you. Okay, Jana.
Friction is a type of contact force in which the 2 objects have to be in contact, in which one of them slows or increases speed of the other.
Okay, thank you. Thank you, Jana. Bravo. So friction is force that opposes motion. Remember that the idea of friction that it opposes motion. Opposes motion, it means that it's in the opposite direction of the motion. Friction always in the opposite direction of the motion. That's why friction, it slows down the object or stops the object, sorry, okay? So since opposes, whenever we have friction acting on an object, so this friction may slow down the object or stop the moving object. So let's look at this example, okay? Now, you can tell me what's gonna happen if the pushing force is greater than friction. Do you think the object will move or will not move? This is an object. Let's suppose that this object is at rest, okay? At rest, it means it's not moving. If the pushing force is greater than friction, will the object move or not? Neda.
It will move.
It will move?
Yes.
Okay, thank you, bravo. Now, what if the friction acting on the object is greater than the motion or the pushing force? what if friction is greater than pushing force? Yes, Muhammad, العادي. Wait. Muhammad العادي, you lowered your hand? Yes, Muhammad. If friction is greater than the pushing force, what's going to happen? Okay, another one. Yes, Zaid.
It will not move.
Bravo. We just said that if the friction is the force that opposes motion. So if a friction is greater than the pushing force, the direction of the motion, the object won't move already, okay? So this is in case of objects at rest. But if the object is already in motion, the object may slow down again or stop moving. So if the force applied is greater than the object's or the and the pushing force, the object moves in the same direction of the force, and if the opposite, the object won't move. Type of friction or an example of friction, which is drag. What is drag? Muhammad Haddad.
Drag, it's a force that opposes motion in liquids and gases.
Amazing, Muhammad, bravo. So drag is friction. So it's a force that opposes motion. Bravo, amazing. And it's only for fluid. And by fluid, I mean liquid and gases. Okay? Okay, Muhammad Al-Aidi, your PC is not working. It's okay. So drag is a force that opposes motion, and it's only for liquids and gases. So whenever I have an object moving through liquids or gases, there is an opposing force acting on this object. We call it drag. Okay? So drag is fluid friction. Bravo. Now, a special type of drag that's it's only, or you can say it's of friction, which is only for gases. We call it air resistance. Haneen, will you define air resistance? Yes, Haneen?
It is a force opposing motion.
Yeah, and what?
But it's only with gases.
Amazing, thank you. So, it is a force opposes motion for objects moving through air or through gases. That's why we call it air resistance. So air resistance is drag caused by gases. Now, since I'm talking about movement and movement through air resistance and it opposes motion, so of course there is factors affecting air resistance. So it depends on the object, the shape, the speed. Let's see who remember what forces affecting air resistance. Yes, Omar. Are you lowered your hand? Okay. Yes, Omar Abu Abed.
So one of the factors affecting air resistance is the surface area of the object.
Bravo. Excellent. Okay, thank you. Another one, Zaina. Zaina Al-Johari.
Is it the speed?
Of course. Okay, well done. So, first of all, surface area. So, how surface area it affects, and what do I mean by surface area? Let's just remember together that surface area, for example, for here, for this parachute, I'm talking about the area that is in contact with the air, okay? The area that is in contact with the air, it's the surface area of this object. So, as the surface area increases, what's gonna happen to the air resistance? Let's think of it together and then take the answer from you. As the surface area increases, so I'm going to have more air trapped under this object, or for example, this parachute. As surface area increases, we're going to have more air trapped under the parachute, okay? Air resistance, the refraction caused by air. So if I have more air, how this going to affect air resistance? Will it increase it or decrease it? Let's see, Lين Arar. Lين Arar, you want to answer? Okay, let's take another one. Yes, yeah. Tala.
It will become more, the air resistance.
Okay, bravo. Again, Tala, will you tell me why it's going to increase?
Because there is more surface area and there is more air trapped under the area, the surface area.
Amazing, Tala. Thank you. So, again, since surface area, it depends, or it means that it's the area in contact with the air. If surface area increases, there is more air in contact with the area. There is more air trapped under this area. So the air resistance is going to increase. Now, the shape of the object. How the shape of the object may affect friction. Now, do you remember streamline shape? Streamline shape is the shape that has a curve in it. Okay, so here I'm showing you two examples of two designs of different cars. One has more streamlined shape than the other one. We do have a streamline, but not that much. So this one, we have a streamlined shape. How streamlined shape affects air resistance? Let's see who wants to answer. Yes, Faisal. Yes, Faisal?
Good morning, teacher.
Good morning.
If the يعني the yellow car يعني the area is smooth.
Okay, bravo. Not the area smooth, the area or the shape is streamlined shape. Since it's streamlined shape, the air flows smoothly, okay? So it's easier to move. Okay, Faisal?
Okay.
Okay, thank you. So again, let's look at these two shapes. One is streamlined, the other one is not very streamlined shape. So because it's streamlined shape, as air is moving above this area, the motion of the air is going to be easier. Since it's easier, so less air is going to be in contact with this object at the same time, which decreases air resistance, okay? Again, streamlined shape decreases air resistance. Why is that? Because the air is going to move easier, so faster, so less air is going to be in contact in the same time with the object. You're raising your hand for a question, or do you want to answer? So if you have a question, keep your hand up. If you want to answer, wait till I ask a question. Thank you. Again, streamlined shape, but here streamlined shape, which is really important in designing airplanes. Designing airplane and the wings of the airplane with a streamlined shape provides higher efficiency for the airplane. So the airplane moves faster, easier, with less air resistance. And it means that we're going to save more fuel and we're going to make the motion of the airplane easier. Any questions about this part?